So what I'm going to do on this video is do some other stoichiometry type calculations. The first problem we're going to do is a gram to particle. And then I'm going to do a gram to mole, and then also do a particle to liter one, just to give you some other examples of everything that you're going to experience. So here is the balanced chemical equation. And again, with all of these problems, we will typically give you the balanced equation for you to do it. And this is called a gram to particle because I'm starting with 46.3 grams of aluminum and I want to go to atoms of copper. So again, with all of these problems in stoichiometry, just keep in mind that it's always usually a three-step process, but it just depends upon what you are given in the problem. So in this problem, since I've given grams, I have to do, my first step is to go from grams to moles. And then I'm going to take the balanced chemical equation and I'm going to see what's the relationship between aluminum and copper. And then finally, I'm going to go to atoms of copper. So again, grams to moles, I'm going to take my 46.3 grams of aluminum and figure out how many moles that is. So I look up the molar mass of aluminum and it's around 27 grams. So I set up 27 grams over 1 mole. So X comes out to be around 1.71 moles, and you want to keep the same number of sig figs as you were given in the problem. So I have 3 sig figs, so I have 1.71, and this is moles of aluminum. And you do want to be very particular when you're doing these problems so you know what you have and what you are going towards. Then I have my balanced equation. I'm going from moles of aluminum to moles of copper. So there I have to use the balanced chemical equation. So I have a 2 in front of the aluminum and I have a 3 in front of the copper. And again, it doesn't matter how you set up these proportions, as long as you can know what you are solving for. So this is moles of copper that I'm solving for. So I have 2 moles of aluminum for every 3 moles of copper from our recipe, our stoichiometry, our balanced chemical equation. So I'm going to take 1.71 times 3 and then divide by 2. So I get approximately 2.57 moles of copper. So then the last step in this case, I'm going from moles of copper to atoms of copper. And the reason it's called atoms of copper is because this is just copper, it's an element. So that's why we're using the particle of atoms. But if it was a different formula, I would be calling it a formula unit or a molecule. That's inconsequential. So I want to know how many atoms I have for every 2.57 moles of copper. If I know 6.02 times 10 to the 23 atoms is for every 1 mole. So again, anytime you're doing a particle calculation, you're using Avogadro's number. So again, we're just repurposing everything we learned in a unit 2. So I cross multiply 2.57 times 6.02 times 10 to the 23rd, and I get around 1.55 times 10 to the 24th, and it should be a big number. Atoms of copper, atoms of copper. So again, it's usually, if I'm going from grams to particles, it's usually a 3-step problem. Again, there are many different ways you can approach these problems, but this is again with proportions. So I'm going to use the same balanced chemical equation for this one, but I'm going to start with the grams. But I'm going to go to moles this time. So I just want to show you an example of this because there's been a couple of these on the worksheets, and it's kind of an interruption into a normal flow. So that's why I kind of want to show you this one. So this one I'm starting with copper sulfate. So I'm going to go again from grams to moles. So anytime you're doing these problems, if you're not starting in moles, you need to get to moles. That's always your first step. So 74.8 grams of copper sulfate. I need to find out how many moles that is. So I add up a copper, a sulfur, and 4 oxygens. It's around 159.6 grams for every 1 mole. So cross multiply, take 74.8 divided by that molar mass, and I get about 0.469 moles of copper sulfate. But I want to know the moles of aluminum sulfate. So this I have to use the balanced equation. So usually this is going from moles of copper sulfate to moles of aluminum sulfate. So I have to use the balanced chemical equation. So in most of these stoichiometry problems, you have to go back to the balanced chemical equation. So I have a 3 in front of the copper sulfate. I have a 1 in front of the aluminum sulfate. So again, doesn't matter how you set up the proportion, just that you set it up the same on both sides. So I'm going to put the moles of aluminum sulfate on the bottom. So I have a 3 in front of the copper sulfate, and I have a 1 in front of the aluminum sulfate. So it's a 3-to-1 relationship. So I cross multiply, I take the 0.469 and divide it by 3, and my number is 0.156 moles of aluminum sulfate. So that's my answer. So again, from the previous problem, I would then go to something else. But in this case, they just want me to go to moles, so I stop there. So it's like a 2-step process. If they wanted me to go to grams, then I would take the molar mass. If I want to go to liters, I would take 22.4. If they wanted to go to particles, I would take 6.02 times 10 to the 23rd. All right, so let me show you one more. And this one is going from particles, molecules, to liters. So why don't you pause the video and see if you could try it, and then come back and see what the answer is. So you are starting with particles, molecules. So you're going to be using 6.02 times 10 to the 23rd to get to moles. So again, I'm starting with particles, I got to go to moles. So I get 7.57 moles of NO. Then I use my balanced chemical equation. I have a 6 in front of the NO. I have a 5 in front of the N2. So it's a 6-to-5 relationship. So I take the moles that I found here, and I set up my relationship to 6-to-5, cross multiply, and I get 6.31 moles of nitrogen. Then I want to go to liters. Okay, so again, once I'm in moles of whatever species I want to look at, I could go wherever I want. I want to go to liters. So it doesn't matter that it's N2. I just use 22.4 liters for every 1 mole. If I was looking for mass, I would take the molar mass of nitrogen. If I wanted to go back to particles, I would take 6.02 times 10 to the 23rd. So it just depends upon what you're looking for. So then I cross multiply, I get 141 liters. So these are just some samples of different kinds of stoichiometry problems. And again, that they are multiple step type of relationships.